8. Question 18. Three concentric circles centered at O. Concentric means the three circles share the same center, and their radius are 1, 2, and 3. So let's look at the picture in the meantime to write down the key information. This is actually telling me for this OB, each segment is 1. So altogether, 1, 2, 3 are the radius. B and C are on the largest circle, and the region between the two smaller circles is shaded. So the middle donut is shaded, as is a portion of the region between the two large circles bounded by central angle BOC. Central angle just means the angle has O as a point, as shown in this figure below. So pay attention to the figure. There are the donut and those two pieces of donut being shaded. Now suppose the shaded and unshaded regions are equal in area. What is the measure of angle BOC? Firstly, this question touches the knowledge of a circle's area and also a portion of a circle's area. So those two are the knowledge part I want to quickly go through, because without that, we can't solve this question. So area of circle is equal to pi times radius squared, pi r squared. Now, what about the area of a portion of a circle? So in this case, it's going to be, let me draw a picture. You have a circle, and now you have an angle. Let's call it theta. And what is the area of this portion of the angle if the radius is r? So the area in this case is going to be equal to the angle's measure divided by 360 degree times pi r squared. The way to understand it is going to be a full circle is 360 degree. Now, if this shaded area's angle is theta, then you just get a portion of the area. So theta divided by 360 times pi r squared. That is sufficient for us to try to solve this question. Now let's see, how do we actually solve for it? It's not easy, and this question, also be careful, it's easy to make a mistake. So let's see how it goes. Firstly, you want to find out the area of the shaded, unshaded are equal, which means they are both half of the total area. So to make things easy, let's figure out what's the total area first. Total area is equal to the big circle's area, because altogether it's a big circle. Its radius is 3, so the total area is going to be pi times 3 squared equal to 9 pi. Okay, now that means the shaded area is equal to a half times 9 pi. Keep that in mind, because I know the shaded area is half of 9 pi. Now I need to figure out how to express that using this angle BOC, which you can assume is theta. The shaded area has two parts to figure out its total area. The first part is a donut. Second part is this small piece of the donut. So let's do this one by one. Shaded area equal to, well, I'm going to call this donut. the donut part plus a piece of baked donut. Just make it easy to understand. You can call it anything you want. You can just call it 1 and 2. Now, what is the area of the donut? Donut in the middle. And I want to say, be careful here. It is not pi times 2 squared. Why? Because the centerpiece is missing. So be careful here. Donut's area is equal to pi times 2 squared, which is the second circle, but the center is taken out, so you need to minus pi times 1 squared. This is going to be 3 pi. Now the piece of donut. This is where you need to use the relationship I'm talking about here. You want to find out the baked donut first, which is actually a similar strategy. It's going to be pi times 3 squared minus pi times 2 squared. That's a big donut, right? 5 pi. But the shaded part is not this whole donut. It's a small piece of it, depending on the angle. So the theta divided by 360 times this pi times 3 squared minus pi times 2 squared, which is basically theta over 360 times 5 pi. All right, their sum is equal to 9 pi divided by 2. So if I'm going to write out this as an equation for theta, what I'm going to get is this. Theta divided by 360 times 5 pi plus 3 pi equal to half of 9 pi. Let's make it easy, just 9 over 2 times pi. Now you need to solve the equation for theta. Well, I can cancel pi in both sides of the equation. Then I can move 3 to the other side of the equation. So I have theta divided by 360 times 5 equal to 9 over 2 minus 3 equal to 3 over 2. And now solve for theta. Simplify it further. 5 and 360, you can cancel it, you will get 72. So this is actually theta over 72 equal to 3 over 2. And you can find theta equal to 108 degrees. So the answer is A. I would say two key things here. The first one is the area of a circle and area of a portion of a circle. The second one is actually a easy to miss point. When you try to find the area of a donut, remember it's pi times the big circle's area square, radius square, minus pi times the small circle's radius square. Thank you.